Explorer is sending back unnerving information to Earth. The Explorer 1, NASA's farthest voyaged space gadget, is right now bridging covered regions of the universe. Pretty much 50 years after its launch, researchers are confused by the terrifying data that this prominent space test machine is sending back to Earth, due to what appears to be a malfunction. Join us as we examine the strange information that the Explorer has been transmitting to Earth during its extended space mission. Experts have long been captivated by learning about the universe's past since the Big Bang, which motivated the launch of Explorer 1 and Explorer 2, among other space missions. Explorer 2 was actually the first space contraption to be launched, departing from NASA's Kennedy Space Center on August 21, 1977. On September 5 of that same year, Explorer 1 was launched, nearly 2 weeks later. Interestingly, it seemed as though the two could switch places like twins. The weight of both probes is 720 kilograms, roughly equivalent to a small car. They were launched during a rare planetary alignment that created a slingshot effect, allowing the rockets to travel from one planet to another. However, they had to move at different speeds and in different directions. On December 15, 1977, Explorer 1 managed to pass its twin. Since then, it has been a crucial asset for learning about various physical phenomena and space mysteries. Explorer 1 became the first space apparatus to carry out a Jovian imaging mission in 1978. At that time, it was about 265 million kilometers from Earth and sent thousands of photos back to us. In January 1979, it completed an extraordinary 100-hour session, capturing 3,750 photographs of Jupiter's storms to create a time-lapse film showing 10 rotations of the planet. By February 1979, it had traveled through Jupiter's moon system, and by March, it had discovered the small ring surrounding the planet. Explorer 1 also made a remarkable discovery when it identified 2 new moons, later named Adrestia and Métis. To ensure the spacecraft was prepared for its flyby of Saturn and to avoid potential collisions with Titan, one of Saturn's moons, adjustments were made. During its orbit of Saturn, Explorer 1 discovered 4 additional moons: Mimas, Enceladus, Tethys, and Dione. After completing its mission around Saturn, experts decided to end Explorer's planetary mission. Both Explorer 1 and Explorer 2 were sent beyond the planetary system at a speed of 325 million miles per year. By January 1990, the new mission, known as the Explorer Interstellar Mission, had begun. One of the most famous photographs in history, depicting the Sun and most of the planets, was taken by Explorer 1 on February 14, 1990, from a distance of 6 billion kilometers from the Sun. These images, commonly referred to as the family portrait, consisted of 60 shots. This brought the total number of photographs taken by the spacecraft to 670, although Mercury and Mars were not visible due to certain factors. Afterward, the spacecraft's cameras were turned off to conserve power and memory for its interstellar journey. NASA also operated other spacecraft like Voyager 10, Pioneer 11, and New Horizons before Explorer 1 surpassed Pioneer 10 on February 17, 1998, becoming the farthest traveling space gadget. Explorer 1 continued its journey for 14 more years before finally entering interstellar space on August 25, 2012. With no other space probe in sight, NASA did not publicly announce this milestone until 2013. Fast forward to November 2018, both probes had officially exited the solar system, with Explorer 2 crossing the heliopause into interstellar space. Explorer 1 was estimated to be 14.5 billion miles, or about 1,550 light-years, from Earth. Since entering the uncharted regions beyond our solar system, the spacecraft has continued to provide invaluable data. For over half a century, it remained in excellent condition. However, in recent years, experts have noticed troubling signs suggesting that Explorer 1 might be malfunctioning. The spacecraft has been transmitting data that appears inconsistent with expectations, leaving researchers puzzled. One of the major anomalies is related to its orientation control system, which helps the probe maintain its position and direct its antenna toward Earth. This system has been sending back data that doesn't align with its actual behavior. Scientists suspect that radiation damage, system wear and tear, or aging of the probe's components might be responsible. Despite this, Explorer 1 continues to send data that is otherwise valuable. It provides critical insights into the interstellar medium, a region beyond our solar system filled with sparse particles and cosmic radiation. These measurements help scientists better understand the boundary between our solar system and the wider galaxy. NASA engineers have been working tirelessly to analyze the data and determine if there's a way to stabilize the spacecraft or adjust its programming remotely. However, given the immense distance and the spacecraft's limited power supply, their options are extremely constrained. While Explorer 1's mission is nearing its end, its achievements remain unparalleled. From its iconic photographs of our solar system to its groundbreaking discoveries of moons and interstellar phenomena, it has reshaped our understanding of the cosmos. As it continues to drift farther into the galaxy, scientists cherish every bit of information it sends, knowing that soon, its systems will likely shut down permanently. Explorer 1 has truly cemented its place as one of humanity's most remarkable achievements in space exploration. Found 2 or 3 odd characteristics in its exhibition, Explorer 1 is, as of now, sending baffling signals back to Earth, giving the feeling that it is sketchy of its area. There is, however, a frightening turn to the issue. Typically, experts have pre-programmed Explorer to go into protected mode or sound an alarm if it goes off track in space. However, so far its radio antenna, which sends data back to Earth, is by all appearances in status, yet the data it has been transmitting is sketchy. The other Explorer is working routinely, taking directions from Earth and carrying them out, as well as gathering and sending scientific data. However, readouts from the rocket's communication and control systems don't precisely align with what is happening inside. According to a NASA official statement, what exactly is happening on board each rocket going toward interstellar space remains unclear. Explorer 1 and 2 both carry a surprising 12-inch gold-plated disc loaded with sound and video messages as a backup in case an extraterrestrial species finds the rocket. The disc contains 35 Earth sounds, 115 live photographs, 90 minutes of Western music, and good wishes from former U.S. President Jimmy Carter as well as former UN Secretary-General Kurt Waldheim. The contents of the space disk are kept in 55 unique languages, so if extraterrestrials take it over, they would likely struggle to translate it. Speculations that the spacecraft is currently under the control of extraterrestrials have been quickly dismissed by researchers. Explorer's ability to function depends heavily on its attitude and orientation control mechanism. Most importantly, it generally keeps its antenna focused on Earth so analysts can accurately receive data. Furthermore, none of the security features designed to protect the spacecraft from danger have been activated. Susan D., mission chief for Explorer 1, stated, "This is a mystery, but it's par for the course right now in the Explorer mission. The rockets are both around 45 years old, which is far older than initially planned for the mission. Moreover, the engineering team is expected to face significant challenges in resolving the issue with Explorer 1 due to its distance from Earth. The spacecraft is approximately 145 billion miles from Earth. This enormous distance presents several complications for the team to investigate carefully. A rescue operation is almost impossible given current technological and logistical limitations. Explorer 1 is far beyond the reach of any space technician or repair mission that we could feasibly send. Its astonishing journey has carried it into the farthest areas of our planetary neighborhood and into interstellar space, where it continues to drift farther away from us every day. Messages sent from Earth at the speed of light take nearly 21 hours to reach Explorer 1's current location. This means that any command or instruction sent by the engineering team takes considerable time to be received by the spacecraft. This delay presents a significant challenge for real-time problem-solving. Once Explorer 1 processes the command, any response or data it sends back to Earth will take an additional 21 hours to return. This suggests that two-way communication between Earth and the spacecraft takes an average of 2 days. Such delays make it extremely difficult to carry out timely troubleshooting or iterative problem-solving processes, which are often necessary for addressing complex technical issues. The engineering team must carefully plan and execute each command, anticipating all possible conditions and outcomes. Unlike missions closer to Earth, where experts can send and receive commands quickly, the long communication delay requires a more strategic and patient approach. Each command must be thoroughly tested and validated on Earth before being sent to Explorer 1. Additionally, the spacecraft itself is over 40 years old, having been launched in 1977. While advanced for its time, the technology on board is considered outdated by current standards. The engineering team must work with hardware and systems designed during the 1970s, adding another layer of complexity to the problem-solving process. The harsh environment of space has also caused significant wear and tear on the spacecraft systems. For over 45 years, Explorer 1 has been exposed to intense radiation, extreme temperatures, and micrometeoroids. These factors contribute to the degradation of its components, making maintenance and repairs even more challenging. Despite these obstacles, the engineering team remains committed to addressing the recent anomalies. They are testing various hypotheses to determine what may be causing the irregularities and simulating potential solutions on Earth. This cautious and deliberate approach is essential, given the stakes involved. Any erroneous command could potentially worsen the situation or result in a loss of communication with the spacecraft. The team is also utilizing the redundancy built into Explorer 1 systems. Like many space missions, Explorer 1 was designed with backup systems to increase its resilience to failures. The engineering team may be able to switch to these backup systems or reconfigure existing components to bypass the problematic ones. NASA stated in a recent announcement that until the cause of the issue is better understood, the team cannot predict how long the spacecraft will be able to collect and transmit scientific data. However, Susan D. is confident that the problem will be resolved, particularly if it relates to the attitude control system, which manages the spacecraft's orientation and communication. The spacecraft's remarkable journey has taken it into the farthest regions of our solar system and into interstellar space, where it continues to travel farther away from us every day.